This is worksheet 12.1 and we're looking at 16 and 18. Find the roots of the parabola, indicate the type of roots, either real or complex. So looking at number 16, the roots are the x-intercepts. So if we set y equal to 0, we can simplify this by dividing both sides of the equation by 2. By doing that, we get 0 equals x squared plus 8x minus 12. So looking at this polynomial, let's first see if we can factor this. So we need the numbers to multiply to negative 12 and add to 8. So if we tried negative 6 and negative 2, those don't multiply to negative 12. If we do negative 6 and positive 2, those multiply to negative 12 but don't add to 8. So there's really no combination of numbers here that would work. So this isn't factorable. So in order to solve this quadratic, we need to plug into a quadratic formula. So negative b plus or minus square root of b squared minus 4ac over 2a. So simplifying that, we get negative 8 plus or minus the square root of 64 plus 48. And then over 2. So that gives us negative 8 plus or minus the square root of 112 over 2. And then we need to simplify this radical here. So if we're simplifying the square root of 112, let's just do a factor tree. So we'll just keep factoring until we have all of the prime factors. So we have 1, 2, 3, 4 2's and a 7. So each pair of the 2's allows us to bring 1 2 outside of the square root. So we have 2 2's on the outside and a 7 inside the radical. If we were to simplify this, this would be negative 8 plus or minus 4 root 7 over 2. If we divide all of these terms by 2, we end up with negative 4 plus or minus 2 root 7. So the roots are at negative 4 plus or minus 2 root 7. And these are both real roots. There are no imaginary parts to these roots, so they're not complex. All right, looking at number 18, we have y equals x squared plus 16. So if we're trying to find the roots of this polynomial, this is not factorable. You could use quadratic formula. A faster way would be to just subtract the 16 over and then square root to undo the squared. So if we take the square root here, we get x equals plus or minus square root of negative 16 is 4i. So here we have roots at 4i and negative 4i. These are complex roots because we have an imaginary part.